Alright, so we're going to see about getting a, got some settings changed here. We're going to see about getting this Digirule here to do some noise, make some noise. We have a number of options for that using the expansion port. And actually a hack or two I've been working on. So we're here connected to the Digirule on our terminal session. It has a bell set up for it, but it's like the system speaker, so it's playing out of the computer, not on the screen, so you won't be able to hear it. But the point is, we're going to play around with the expansion port. So we've got these accumulator points, accumulator and pins forwarding to this. So we'll set the accumulator value with these and see what kind of output we can get. So we've got this. We've got the Digirule's expansion port hooked up to these pin headers. So I've got ground and A hooked up to this piezo electric speaker thingy. So we'll see if we can get it to make some noise. Hopefully something that actually you can hear. And also hopefully that piezo is not 5 volts, so we'll find out. So we've got clear bit of memory to deal with here. We should be able to set our pinouts here and set up some loops. Let's see if I can remember some of this stuff. So let's start by editing our memory field. We'll start with setting the speed, which is we'll need to record this. We'll go there. Yeah. Out. We'll set a marker here for pin out. Alright. And now we can skip around. Or can we? Instructions. Go to speed. Where's speed? There it is. These are speed values. Mark that S. Alright, so then we can jump to our instructions. Except that doesn't jump to our pins. Here we go. There's the instructions, our pin out, and our speed. Alright. So we'll set our speed value using 0.2. We'll set our value to, let's do 1/4 of a second. 8.0. First we'll set the speed, and then we'll probably have to populate the accumulator. Go back to our instructions, copy literal to the accumulator, which is 0.4. Literal value will be, oh, there's helpful code right here. I will do 0.1. Maybe that should be something different. No, 0.1 is right. Okay. And then we'll set pin out, which is C4 instruction, to the A pin 0.1. Alright, see what that looks like. We got a program counter. We set speed to 8.0. We copy literal into the accumulator, 0.1. We set pin out 0.1. And then we'll probably want to flop that around a little bit. So let's give A, I'm trying to do some kind of like pulse width modulation, see what we can do. We'll switch it around. So let's go to edit memory. So next field is 0.6. And we'll set that to copy LA, which I believe is 0.4. Yep. We're going to do another copy literal to the accumulator. This time we're going to set the accumulator to 0. And then we're going to do another pin out command, which is 0.6. And we're going to set that for the A pin. Alright. Let's see what we've got again. Oh, that's the wrong. Yeah, that should be pin out. Pinout is 06, not 08. So let's redo this instruction. Edit 08. The instruction is pinout, which is... Oh, I read the wrong one. C4. I was looking here. That's the address, not the machine code. And our output for it is 01 still. So let's look at that. So we've set our speed. We copy 1 to the accumulator. We set the accumulator to A. And we copy 0 to the accumulator. We set the set A to... we set the accumulator to A. Alright, so it'll be 1 0 1 0 back and forth as fast as this goes, but we need to jump back. So let's do our edit this field. We want to do a jump. Jump is 2.8. Jump instruction, and we're going to jump up to this value. Or I guess we don't really have to do that. Let's do it. There will be a little bit of a pause. Yeah, let's do it. Okay. So this is just going to repeat setting A high and low over and over again. So let's see what happens. See if we can hear this. I'm going to hit go. So you can kind of hear. I don't know if you can hear it. 3 volts might not be enough for this. I think I have a different one. Let's see if this one's any better. This is the positive side. Yo. There we go. Alright, so that sounds a bit better. I'm also kind of curious about the following, though, because this is something I was messing around with. Oops. Probably should set pin A to low. Let's see how I do that. Let's set the accumulator. So it's still buzzing right now. It's in a high state. Why is it buzzing? That's interesting. Well, that's useful. So this one doesn't want PWM. This just wants a high value or a low value. Well, that's interesting. Cool. Well, I think we might have already solved the problem here. So this is I think this is an active buzzer. And that might be why it's working better with the solid power. So it turns on and then it runs. That might be the end of this. That might be the solution here. All done. Have a nice day. There is one other thing I wanted to mess around with, though. Just in case we do only have a passive buzzer. There we go. Start it up again. Yeah, and all you can hear is this click. It clicks when it goes high and it clicks when it goes low. So that's something that needs more modulation. So let's see what we've got here. Set the program counter back to 0. Let's inspect. Let's set our speed to something a lot faster. So edit 0 0. That's wrong. I want the speed. I want to change the value. Set it to 0 0. Maximum speed here. Alright, so now our speed went from 80 to 00, so this is max speed. Let's see what it does. I can't say that we would have wanted anything. Can't say we want anything more than that. That was pretty good. Very high pitched, very annoying. Yeah, moving this around also might have disconnected me. Let me get reconnected here. Not bad. So we're essentially creating some pulse width modulation here. Oh, let me reset back to 0 at the program counter. There we go. So we set our speed to 0, and now we've got like PWM essentially. But I am interested also in what happens if we adjust this. So let's do something a little bit more interesting. Let's increment a RAM. There we go. Increment RAM. So we're going to increment the RAM value before our jump. So let's do, see where we are. C4, 0. There's our jump back to 0. So before we do our jump back to 0, let's overwrite our jump to 0 with an increment for the speed value. So let's edit 0 alpha to 1e. And we're going to jump back to, or we're going to increment rather, this is 0, 0, so this is 0, 1 address. Yeah, that's right. So 0, 1. So that'll increment that. Then right after that, we want to do our jump, which I think is 2, 8. There it is. 2, 8, and we'll jump back to 0, 0. That'll do it. So now we set our speed to 0. We copy 1 to the accumulator, and we set A to the accumulator value. Then we copy 0 to the accumulator and set A to the accumulator value. Then we increment memory space 0, 1, which is this speed, and then we jump back to the speed instruction. So this should actually increase the speed as it goes on, and we can see what kind of tones we get out of it. Let's see what happens. Let's see what happens. I don't know if I want to do a wait, but we'll just see. Bring it up so you can hear it. Yeah, that got slow fast. So we made it to 2, 3. Set program counter back to 0. Disassemble memory. Yeah, our speed got to 2, 3. So let's edit the speed back to 0, 0. I think it sounds a lot better with that. Let's see. Let's skip the jump. Let's not do the increment. So let's edit 0A back to jump, which is 2, 8. And we'll jump back to 0, 0. Yeah. 0, 0. 0, 0. Got that extra jump. It doesn't matter. Alright, so let's set our speed. Let's edit 01 to, let's do 08. And see what that sounds like. It just sounds like buzzing. Back to 0. Edit 01. Whoops. Edit 01. We'll set it to, let's just double it, see what it does. It's kind of a lower sound. So let's actually just disconnect this, play around with it. The other thing about this is we actually get full control over the instructions here. If I can hold it so you can see it. Go to memory spot 0. That's 0, 2, which is our speed set. We set it to that. Let's set the speed to 1, let's say. Let's see what it sounds like. Not bad. Stop that. Go back to the beginning. Set speed back to 0. Store that. Back to the beginning. Start. Yeah, so we can see about making some kind of buzzing thing happen here. Yeah, we can do that. The other problem, though, is that this this ruler executes all this code at full speed. So if we want to give it some kind of delay, I don't think that there's an option for that, except setting up an accumulator value, counting it down and decrementing it until, and then jumping if the accumulator is 0. So we'll see how many values we get, because I don't think there's just a standard weight. The speed, actually, though, is actually interesting. Executing instructions at the maximum rate possible. So I don't know what that maximum rate is. Setting it to 1 millisecond is probably a good intermediate thing. But to be frank, this active buzzer is probably going to be the solution here, since you can just turn it on and off. And we can run it at whatever speed we like, because then it can execute instructions at whatever speed we like. But let's try 1 just for the sake of messing around here. Let's go back to this mode. Debug mode. There we go. We'll display our memory. Set the program counter back to 0. Disassemble. Alright, speed 0. This is our area where we're doing this stuff. But let's set our speed to 1. So let's edit 01. Set it to 01. Edit. Go. That's not terrible. Pretty audible. But at 1 millisecond, we need 500 iterations to get it to do anything like that. Or to give it a, you know, like a on-off kind of thing. So let's see if we can do that. Let's go back to our instructions. Alright. Reset our program counter. Alright, so we've got speed 01. We'll keep that. This whole area is where we set the buzz. But it's like we want to repeat this and then set an off, like a no ops, and to wait. So let's see. This speed is executing these instructions 1 millisecond. So 1, 2, 3, 4. 1, 2, 3, 4, 5. And then jump. So we'll have to give it the same amount of no ops, but we're not going to jump to the beginning. I'd much rather move this around a little bit. Let's give ourselves a little bit of room, all right? So this is our current program code here. Yeah, all right. So let's move that down here. We're going to move it to 2.0. Just so it's a little bit easier to read. So let's edit 2.0. And we're going to set our values right here. We're just going to copy these ones up here, though. So 02, 01, 04, 01, C4, 01, 04, 00, C4, 01, 28. Enter. Let's display that. Make sure that looks good. Yep. Looks good to me. Alright, so 2.0 is our run for this. And then here's our jump, where we go back to wherever. So we're probably gonna emulate some no ops here, so that it just has kind of a weight that it does. And then let's look at our jumps. Decrement RAM, jump if 0. Bit test RAM, skip if clear, skip if set. Jump address indirect. So it looks like we're going to need a RAM spot. I don't think it's based off the accumulator. Subtract literal from accumulator. So if we subtract literal from the accumulator, we'll set a Z flag, and then we can test that. But I think this decrement RAM jump if 0 is going to be just fine. Increment RAM. Yeah, let's do this. Let's pick a RAM spot. And just for fun, we'll pick 5.5. So let's edit memory address. Well, let's do kind of an initialization. So let's fill memory spot 0, 0 to 0F with 0 zeros. We'll wipe that out. Good, so the first thing we're going to do is set a RAM spot. The RAM spot will be, let's do 60 just for fun. So this is going to be the initialization of our program essentially. So edit 0, 0, and we're going to set a RAM value, set a literal to a RAM value, copy literal to RAM, that is 05. The literal we will copy to RAM will be 256. Let's do 128. Now let me do some quick maths in my head. Isn't that just F0? No, it's 80. Okay, so we're copying. Where am I? 05. Copy literal to RAM, and let's do the first number. Yeah, first number is the literal, and then we'll set it to address 55. There we go. Copy literal to RAM. We're copying that value to space 55. And then when it runs through, let's see. So we copy that value, and then we want to run from 20, except when we jump, we're not going to jump. We're going to see if the decrement value, decrement RAM, jump if 0. Whoops. Yeah, it's no fun. My markers, my beautiful markers. Let's go back to this page. Let's get to our instructions. Mark instructions. Get to our speed, mark speed. Go down to here, mark pins, DEC, DCE, DECR. I keep pressing some button. Come on. Speed. Pin. ECRJ. Mark J. Let's do that. Okay. So after we toggle this pin out, we're going to do a decrement. Wait, that's not right. Is it? RAM at value. So decrement FA, the RAM at value FA is 0.5. Post conditions, the RAM becomes 4, and then it is not jumped, so it goes to halt. Since the result is 0, it executes the halt function. So it runs the next instruction, or it skips it. I think this is right. So the preconditions, this address FA is at value 1. Decrement RAM value FA, and if it is, jump to the halt. Since the result is 0, execution continues with the halt instruction. This jumps to 0. So if the result is 0, it does the jump. Otherwise it runs the next command. Alright, so this is where our repeat is. So we want to edit to A with our jump. And we're going to change that to decrement, which is 1F. We're going to test RAM value at 5.5, I believe. And if it is 0, so 1, Z is 0, it jumps back to the beginning. Since it is not, it continues with the jump instruction. So, if the value is 0, it jumps. If it is not, it does the next instruction, which is a new jump. The jump is going to be to 8, and we're going to jump back to this where we're modulating some more. Now, if it does hit 0, then we're going to... We're going to need to reset the value. Well, let's look at this real quick. Decrement 55, jump back to 2.0. But if it is 2.0, then we're going to want to do a copy LR 80, which is 058055. We're going to reset the counter. So let's do this. Let's do this. And then program counter back to 20. Disassemble the memory. So if this value is not 0, it's going to jump back to here and repeat the process. Now when it's done with that process, it will go down to here at 2E. And then at 2E, we're going to need to reset the value. So edit to echo. We're going to set that to this literal, which is 05. Copy literal to RAM. 5. Copy literal to RAM. Position 5.5. There we are. That looks right. So we're resetting the counter value. And then we're going to... I think we're going to no-op. So we've got the speed is set. Oh, that's a good point. The speed doesn't need to be reset. This jump value should actually go back to 2.2. Yeah, let's edit to D. We're going to jump back to 2.2. There we go. That looks better. So we set the speed. Copy LA, pin out. Although that speed should probably go at the beginning. It doesn't matter. This is fine. This is fine. So we reset the counter value. And then after our counter value is reset, we're going to do nothing for the same amount of time. Now, the same amount of time is reflected by this, this copy LA no-op thing. So we've got sets of instructions that we're repeating here. 1, 2, 3, 4, 5. and then essentially the jump is 6. So we're going to do 6 no-ops, or we're going to reset the value here. So let's add 6 to that since we're doing 8-0 for the value. Let's edit to F from 8-0 to 8-6. Yeah. That's 2 extra. That's 6 extra. Well, technically it should be 6 times if we're just going to do a no-op. Yeah, it doesn't make any sense. So we have 6 instructions. We'll do 3 or we'll do double. So 128. Let's do FF. Yep. Alright. Let's edit to F to FF. And that'll decrement. But that means we're going to do twice the amount of instructions, which means we're going to have this jump. So we'll do no-op, jump. Because we were previously doing 1, 2, 3, 4, 5, 6 instructions. And now we're only going to do, we are going to decrement. So we need to do 1 no-op, 1 decrement, and 1 jump. Yeah. So let's see what we've got. Copy that there. 31, we'll do a no-op. We're going to decrement. I forget what that is. Let's do that. Decrement, jump. This is 1F. So we'll edit 32, do 1F. Oops. Edit 32, 1F. We're decrementing 5, If it reaches 0, we're going to jump, but if it doesn't jump, we're going to 2-8 back up to our no-op, which is 3-1. And then if it does, then we're going to reset the value. 1F 5. That's not right. Let's see what we've got here. Set speed. This is our repeat. So if this value is 0, or if it's not 0, then we'll jump back to this one and we'll repeat it. Now when that number gets to 0, we're going to jump down to here. We're going to fill it with FFs. We're going to do a 1 wait. We're going to decrement. Then we're going to jump. Oh, actually, we should set this to 0. Because the last thing, copy LA 0. No, it'll be off. Yeah, so it'll be modulating here, and the last thing it'll do is turn it off, and then it'll go down to here. Then we'll repeat. Jump back up to 31. Now, when it does hit 0, it's going to jump, and it'll be at 36. And when it hits 36, we're going to reset the value of 5 back to that. So let's edit 36. Once that happens, we're going to reset the literal value, which is 05. Copy the literal value to RAM. 05. We're going to set 80 in RAM position 55. And then we're going to jump back to 2-1, I'm pretty sure. So that's 2-8, 2-1. Enter. Good. Let's set a program counter to 2A and disassemble again. P26. I think this works. Let's find out. We've got our speed set already, so technically we want to pick this up at 2-0. that looks right. But we do have to copy our value here. So let's run this code at the beginning here. Well, technically, this is us setting our value. So let's edit 03 to be a jump command to 20. There we go. So we set our RAM value. Then we jump to 20. We'll set our program counter to 20. Then we set our speed to 1. We copy 1. We set A. We copy 0. We set A on, off. We decrement that RAM value. And if it is 0, we jump. And if it is not 0, we'll jump back to 22. So we should modulate here until the RAM value at position address 55 gets to 0, which should be 128 milliseconds. And then we copy 256 into that RAM position. We do one wait. We decrement that RAM position. And then if that RAM position is 0, we jump back up to 31, which is our no op. And then when it is 0, we copy LR, copy the value back to 55. We copy the same values before, 80. And then we jump back to 21, which is, ooh, not 21. We jump back to 22. Yeah, okay. There's a bug. That would be edit 3 alpha. It's 2.1. We want it to be 22. Good. Program counter is 0. Set the value, jump, and move from there. Let's see what happens. Perfect. First time. All right. So that was a neat little academic experiment here, just because we're messing around here. So we have this value flapping back and forth. I'm actually kind of interested to know what happens if we reset that speed value. So let's edit to 1. We'll set it to 0. I don't know how much faster it is than 1 millisecond. Probably a lot, but we'll find out. Set our program counter back to 0, 0. Let's see what happens. Well, that's not bad at all. So this is our experiment to be able to run this with just the piezo electric, but we're probably going, this is the passive buzzer, but we're probably just going to run it with the active buzzer because that's just too handy. Rather than doing these repeats where we're counting down RAM positions. There's our 55 value. Pretty neat. So this also means that when we have this position set up, we can probably do, well, let's go back to our countdown timer. So let's save the, I don't really care actually. Yeah, I don't really care. I understand how this works, and I have a video of it, so who cares? Let's wipe the memory. We'll load from save position 7. Now, somewhere in here is our repeating value. I believe our program counter 67. Set program counter 50. Disassemble. Yeah, there's our COM out. That's our bell. I actually might have to use the assembler for this, but I don't think I can change that. Yeah, I can't. And I can't jam the memory in here because I can't move everything down one. So I'll have to use the assembler to insert it in there. But basically, but we are copying this literal to the accumulator. And we are setting this to A. So what is A set for? The value for our expansion slot. I think that is a flag, I think. Status register. There we go. No. Go to our expansion slot. Dun, 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 dun. Expansion port. Copy accumulator to those pins. Configure the pin direction. Yeah, I don't think you get to preview what that value is. Pin mask, expansion port for the accumulator. Yeah, you can set it, but I don't think you can view it. So I actually don't know if it's high right now. Let's see. Let's use B, because we're going to set pin for B. Pin out. Yeah, we need the accumulator value, and then we'll pin out A. So I mean, 2 spots in here. Let's see if we can squeeze this in. So copy literal to the accumulator. So let's edit 5E. It's currently 07. We want it to be 01. So we're setting 1 value, and then we're adjusting this. Did I screw this up? So we do that. We set the speed. Copy literal to the accumulator. We set our speed. And then we swap. And then we calm out, and then we jump. But that's a single byte of instruction, so I don't think that works. Copy literal accumulator. Set speed. Swap those RAM values. Calm out and then jump. Yeah, I don't think I can squeeze it in there. There's just 1 byte. I'd like to be able to turn it on. Unless we maintain the same speed. I don't remember what the speed is set to before that. Yeah, speed is 0. So maybe we do the speed adjustment here. Alright, this is a little bit of a hack. 6, we'll set our speed up there. That'll free up 1 instruction for us. And now we can reuse this and reset the speed. It jumps back to the swap and does a calm out. So we'll get the calm out, but we also want to do this pin out. And it does use 2 bytes. We might be able to do this. So we're going to do, we've got the accumulator populated. Yep. And we'll do, I think we're going to have to do pin B actually, because I don't think that's going to fit otherwise. This positive side, ground, pin B. We can do that. That'll fit. We can reach that. Come on. Yeah, we'll do pin B. Pin B is 1, 0. So we've got the speed set here. Calm out, jumps back to 6, 1. Copy a little accumulator. Yeah, we'll write over this one. So let's edit 5F. We've got 2 bytes. And we'll set our pin out, which is C4, to the Bravo pin, which is 02. That might just fit. I think that looks right. Let's disassemble from 4. Oops. Disassemble from 4F. Our calm out. See, this is a little bit higher. For F. Oh, right. Let's do I4. Oops. I4E. There we go. There's our jump. There's our speed. Yeah, so somewhere we're jumping to 5.5 is where we get our repeat. And then we reset these values. And then we copy 1 into the accumulator. Then we set Bravo to the accumulator value. Then we swap them. Then we make the bell. Wait. Actually, we're not doing the bell because that calm out's not going to work now. The calm out's going to send whatever 01 is to this terminal screen because it was previously 07. We would need to change that back, but we're not going to do that. Let's kill the calm out then. X4, we'll set that to no op. I4E. Alright, this looks good. We swap, we no op, and then we jump back up to 6-1, which is swap, no op, 6-1, but this is already set high. Yeah, it's a single. Yeah, we can't do anything with that. Alright, this is fine. So let's set our program counter to 5.5, and we'll run it as if the timer ran out. So this is where it's going to start executing instructions, because that's where it jumps to. I don't remember where it jumps to 5.5. Let's see. Possibly up here. Yeah, there's a jump 5.5. So let's set disassemble from 2.0. Yeah, jump to 5.5. That's 2 zeros too high, so let's disassemble from 1F. There we go. Yeah, there's where it jumps to 5.5. 5.5. Alright. Yeah, we'll set our program counter to 5.5. We'll see if this works. So it won't generate a terminal bell, but it will, it should turn this on. Oh, but this one's gonna, it needs to be the active buzzer for, in this case, since we're just turning it on and leaving it on. There we go. That means it'll just, yeah, it'll just turn on. Why is, oh, it was set to B, that's right, because it didn't fit. Let's try this again. There we go. Low pin would be here. Let's, B's already set high, it doesn't matter. So we need to see if this reaches here to here. Nope, not quite. There it is. Also, when we stop the program, I think B is still set high, though. Sure is. Okay, so that's one thing in favor of the using the passive one, because it modulates, and that way when the program stops, the buzzer will stop no matter the state that the pin is set in. But definitely made some progress here, so we'll be able to mess around with that, and this Digirule will become much more annoying. I also now understand the difference between our active piezo and the passive piezo. But I didn't really have a problem with that with the passive piezo. I thought it was just fine. I made some pretty high-pitched noises too. We were essentially making our own pulse width modulation. And previously, I'd been messing around with it by setting that. You know, I saw that it was the calm out. Where is it? 5. Yeah, this calm out was set. So we were setting this this value 07 for the calm out. So the terminal would flash, but I would have to have a terminal connected to it. But I realized that if I set it to the TX pin on the serial output, I was able to send out blasts of data at different speed on the COM port, and it would play music through a speaker. You know, it would modulate the speaker, so it would make an annoying noise, which is the point of it. So this is, you know, if you set it down somewhere and plug in the interface on it, I've got some 90-degree pins here for it, then that might make a bit of sense to make your Digirule more annoying. But I would rather have more of a flush mount fit where I can, you know, fit this right on there and then travel with it on. Yeah, so that's I think that's it for now. We'll mess around with this later on.